Hello, pre-calculus students. This is Mr. Medic. I'm going to give a lesson today on conic sections using parabolas. And remember our cone. And conic sections do a good job of describing how a cone and an inverted cone attached to the same point right here, going this way, you can create various mathematical constructs by cutting through them. In this case, you would cut through the slice of an edge like this at this angle, and it would create a parabola. You can see that would be a parabola. And that parabola can face up, face down, or it can face to the left, face to the right. Got a variety of directions it can face. You'll see all of those. So, pre-calculus students, we are now in Chapter 10, and we started with circles because I wanted you to have some experience completing the square with two variables. We're going to be doing that pretty much this entire unit, so you have to get used to that. Now we're going to talk about conic sections in 10.1, which is about parabolas. There are four basic forms of the equation for a parabola. The simplest form is x squared equals 4py. Now I know that you're going to be fighting a bit of your memory here because you're used to using the vertex form. The vertex form is kind of here, but we're not looking at it in that way. We're looking at it instead in terms of a conic section. So conic sections all have some similar processes, and we have to look at parabolas in terms of what's going on with the other processes. So like I said, this is the simplest one, and this is the one we're most commonly used to. I can get y by itself here by making it y equals 1 over 4p x squared. Let me make that x squared a little larger so it's a little obvious that the 4p is in the denominator of that fraction. Now this is the way the book writes it, but this way also means the same thing. This is only when the vertex is at 0, 0. If the vertex is at 0, 0, it's going to look like that, and it's going to open up like this. Okay? Now, if p happens to be negative, then it'll open the other way. Now, if the center happens to not be at 0, 0, then this is going to modify it. H will modify it to the left or the right, and K will modify it either up or down. Okay, this is a vertically oriented parabola. This, on the other hand, is a horizontally oriented parabola. In this case, I would write x is equal to 1 over 4p y squared. And as you can see, the x and y's here trade places, don't they? So what was up is now going to become to the right. So if p is a positive number, it opens to the right. If p is a negative number, it's going to open to the left. Okay? And now what is a parabola in conic sections? In conic sections, a parabola says you've got this line, and now there's this point that's above it. And you're going to find all of the points that are the same distance from this point as they are from this line. So that would be that point to begin with. Let me change colors here to green. And then if I look for another point over here, that's about that distance there, and that distance there, that's about the same distance. So there's another point there. There's another one that's reflecting that's coming over there. And as I get further along the line, it's going to start curving further and further up. And that's where we get a parabola from. And that distance here is p. This is also p, but it's p in the opposite direction, so it's called the opposite of p. Okay. So that's what parabolas look like. Now, if we're talking vertical, p is the distance from the vertex up to this point. This point is called the focus. Now, there's only one, so it's a focus. It's like a cyclops. If p is negative, instead of it going up to get to the focus, you're going to go down to get to the focus. Okay? That's in a vertically oriented parabola. In a horizontally oriented parabola, the same thing works, but instead of up, you go to the right. Instead of down, you go to the left. Okay? So that's your basic understanding of conic sections and parabolas. Okay, so now we're going to look at some specifics. Let's say that we have a parabola that has a focus at 0, 4, and that its vertex is at the origin at 0, 0. So I'm going to make a little sketch of this. The first thing I need to know is whether this is going to be vertically or horizontally oriented. So I'm going to make a little sketch. I'm going to make each one of these spaces stand for 1 unit. So that's 2, and that's 4, and that's -2, and -2. And I know my vertex is there, and it says that the vertex is at 0, 4. Well, I can tell right now that because my vertex of this parabola is right there and the focus is right there, this is going to look like one of those horizontal ones that we saw. Specifically, it's going to open up. It's going to open up in this direction, which means that the line that this is equidistant from is equidistant in the other direction. So that means it's going to go right here through y equals -4. And this has a name. This line is called the directrix. The directrix is at y equals -4. Now I know that because P is up here. Not P, but the distance P is 4 from the vertex to the focus. So that's P, and it's 4. So that means that the parabola, and I'm just roughly drawing this, is going to look something like that. Okay, going in that direction. That's just a little quick sketch. The reality is I don't care too much about where the specific points are. I know I've got my parabola in there. What I do want is to get my equation. Well, the equation that this fits is that first one I showed you, x squared equals 4py. Okay, now I just told you that p is 4. So I can plug p into there, and I'll have this equation. Specifically, it's x squared equals 4 times 4y. So x squared is equal to 16y. That's the equation of this parabola. It's really simple because it opens upward, which is the first equation.